On the morning of June 6th, 1944, as the first wave of American soldiers waded ashore at Omaha Beach, a young Army lieutenant named Harold Everett stood in a converted English manor house near Bushy Park in London, feeding punched cards into a machine the size of a wardrobe. The machine was an IBM Type 405 alphabetic accounting machine. The cards it was reading contained the serial numbers, blood types, and dental records of 156,000 men scheduled to land in France that day. Everett was not a soldier in any traditional sense. He had never fired a rifle in anger. He had been recruited straight from an IBM sales office in Cleveland, Ohio, sent to a 6-week Army orientation course, given a uniform, and then assigned to do exactly what he had been doing in civilian life: make IBM equipment run.
He was not unusual. By the summer of 1944, the United States Army, the Navy, the Army Air Forces, and a dozen federal agencies responsible for running the war economy had collectively deployed more than 1,400 IBM customer engineers across every theater of the war. They were in England and North Africa. They were on transport ships in the Pacific. They were in the basement of the Pentagon, which had been designed partly around the space requirements of IBM's tabulating equipment. They were in converted warehouses in Queens, New York, where the draft board processed induction notices at a rate that would have been physically impossible without them. They were, in a phrase that appeared in a 1944 Army procurement report, as necessary to the operational infrastructure as motor pool mechanics.
This is the story of why a company that made office machines became indispensable to the largest military mobilization in human history. It is the story of a technology most people have never heard of: punched card tabulation, and of the man who built it into an industrial monopoly so complete that when the government needed it, there was no alternative. And it is the story of what happens when a war is run not just by generals and admirals, but by data. The card that started everything. To understand what IBM did during the Second World War, you have to go back to 1890. In that year, the United States Census Bureau faced a crisis. The population of the country had grown so fast, from 50 million in 1880 to 63 million in 1890, that the Bureau's statisticians estimated it would take 13 years to manually tabulate the results of the census just completed. By then, the 1900 census would already be underway. The Bureau was drowning in paper. A statistician named Herman Hollerith had a solution. He had been thinking about the problem since working as a young clerk on the 1880 census, watching teams of men bent over ledger books, transferring numbers by hand from survey forms. Hollerith's insight was mechanical. Reduce every fact about a person to a series of holes punched in a card, and build a machine that could read those holes electrically, sorting and counting at speeds no human clerk could match. He had been developing the idea for nearly a decade. The 1890 census gave him his chance.
Hollerith's tabulating machines processed the 1890 census in 2.5 years. The government saved an estimated $5 million. The technology spread quickly to railroads, insurance companies, and large manufacturers who needed to track inventories and payrolls. Hollerith founded a company to lease the machines and sell the cards. He called it the Tabulating Machine Company. In 1911, after a series of mergers, it became the Computing Tabulating Recording Company. In 1924, under its new president, Thomas J. Watson, it was renamed International Business Machines. Watson understood something Hollerith had not. The machines were not the product. The service was the product. IBM would lease the equipment, train the operators, provide the cards, and send its engineers to maintain everything. A customer who signed an IBM contract did not simply buy a machine. He bought IBM.
Watson's monopoly of the mundane. Thomas J. Watson Sr. is remembered today, when he is remembered at all, as a salesman. The man who put the word think on plaques in every IBM office, who demanded his salesmen wear white shirts and dark suits, who built one of the most aggressive corporate cultures in American history. What is less remembered is that by 1939, that culture had given IBM an effective monopoly on punched card tabulation in the United States. The company controlled roughly 90% of the market. Its nearest competitor, Remington Rand, held most of the rest. And the difference between IBM and Remington Rand was not primarily the machines. It was the engineers. IBM trained its customer engineers, the men who installed, maintained, and repaired equipment in the field, with a rigor that bordered on obsessive. Watson had built a training school at Endicott, New York, where new engineers spent months learning not just the mechanical principles of tabulating equipment, but the specific quirks of every model IBM made. They were taught to solve problems in the field without calling back to headquarters. They were taught to understand the customer's business deeply enough to redesign data flows when a new problem arose. An IBM engineer who showed up at a factory in 1939 did not simply plug in a machine and hand over a manual. He interviewed the factory manager, mapped the production process on paper, configured the card format, wrote the sorting sequence, trained the operators, and returned every month to check that everything was running correctly. It was the most sophisticated service organization in American industry.
When the Roosevelt administration began expanding the federal government in the late 1930s, first for the New Deal, then for rearmament, it turned instinctively to IBM. The Social Security Administration, created in 1935, was built almost entirely around IBM tabulating equipment. Its first task was to assign Social Security numbers to 26 million American workers and begin collecting payroll contributions from 3 million employers. Without punched card tabulation, the agency could not have functioned. Within 2 years of the program's launch, the Social Security Board was processing 600,000 wage reports per month. The equipment doing that work was IBM's. The men keeping it running were IBM's. When the Selective Service Act of 1940 created the first peacetime draft in American history and required the registration of 16 million men, the Selective Service System called IBM before it called almost anyone else.
The draft and the machine. The scale of the challenge was unlike anything the federal government had attempted. Under the Selective Service Act, every male between the ages of 21 and 36 was required to register at a local draft board. Those registrations had to be processed, classified, tracked, and updated as men were inducted, deferred, transferred, promoted, wounded, or killed. The addresses changed, the classifications changed, the Army's requirements changed every month as planners adjusted production targets for different units and specialties. The paperwork was staggering.
Selective Service Director Louis Hershey turned the problem over to his statistics division, which turned it over to IBM. The solution was a national punched card system in which every registrant was represented by a MasterCard containing his personal information, his draft classification, his induction status, and his physical qualifications. Local boards punched new cards when a man's status changed. Those cards were batched, shipped to regional processing centers, and run through IBM sorters and tabulators that updated the master file and produced reports telling the Army exactly how many men of a given age, physical category, and occupational specialty were available for induction in any given month in any given state.
At its peak, the Selective Service System was maintaining records on more than 45 million registered men. The equipment processing those records occupied 4 floors of a building in Washington, D.C., staffed around the clock in 3 shifts. IBM engineers worked alongside Army clerks to keep the machines running.
When the card format had to be revised, which it was 3 times during the war, as the Army's classification system changed, IBM engineers rewrote the processing sequences and retrained the operators, usually within days of receiving the new requirements. The Army's manpower planners received their monthly reports on schedule. They almost certainly did not think about how.
The arsenal and the ledger. The industrial mobilization of the American economy between 1940 and 1945 was, as William Knudsen understood, a production problem before it was a strategic one. But it was also, less obviously, a data problem. Producing 50,000 tanks and 200,000 aircraft and 8 million rifles required coordinating the output of tens of thousands of factories, tracking the consumption of hundreds of raw materials, and managing supply chains of a complexity the country had never seen. The men running that coordination in the War Production Board, the Army Ordnance Department, the Navy Bureau of Aeronautics, and dozens of other agencies were doing it with punched cards.
The Army's Statistical Control Division, established in early 1942, was built on a simple premise: that the Army was generating enormous quantities of data about its own operations, procurement, supply, maintenance, personnel, transportation, and that most of it was being wasted because no one was systematically analyzing it. The division's first director, a Harvard Business School professor named Edmund Learned, brought in a team of young analysts and set them to work building a reporting system that could tell senior commanders on a weekly basis exactly where every critical resource in the Army was located and what condition it was in.
The equipment they used was IBM's. The men who kept it running were IBM's. At Army Air Force's headquarters at the Pentagon and at forward commands in England, North Africa, and the Pacific, statistical control detachments operated tabulating rooms that processed the operational data of air campaigns in near real time. When the 8th Air Force in England began its strategic bombing campaign against Germany in 1943, the Statistical Control Unit at High Wycombe was processing bomb damage assessment reports, mission records, and aircraft availability data daily, producing analyses that went directly to General Ira Eaker and, through him, to the combined chiefs of staff. The men doing that analysis were mostly young officers fresh from college, many of them trained at a special Harvard course the Army had set up specifically to produce statistical control officers. The equipment they used was IBM 405s and 601 multiplying punches, maintained by IBM engineers assigned to the unit.
The engineer in the field. What made IBM's role different from that of any other contractor was the presence of those engineers. A Liberty ship delivered to the Navy was, once accepted, the Navy's problem. A tank delivered to the Army was the Army's problem. But an IBM tabulating installation was never entirely the customer's problem, because IBM's business model required that it remain partially IBM's. The lease agreements that governed IBM's equipment gave the company the right and the obligation to maintain it. IBM engineers were, by contract, always present.
In practice, this meant that when the Army deployed tabulating equipment to a new theater, IBM engineers went with it. When General Douglas MacArthur's headquarters in Brisbane, Australia, set up a tabulating room to process logistics data for the New Guinea campaign in 1943, a team of IBM engineers arrived within weeks to install the equipment and train the operators. When the Fifth Army in Italy needed to expand its statistical reporting after the breakout from Anzio in 1944, IBM engineers were flown in from England. When the island hopping campaign in the Pacific created new forward bases faster than the Army could train tabulating operators, IBM sent engineers who could both operate the machines and train local personnel simultaneously.
The engineers were not soldiers. Most had received minimal military training.
Many were young men who had been deferred from the draft specifically because their skills were classified as essential to the war effort, a designation that IBM had lobbied for and received early in the war. They wore uniforms when required, ate in military mess halls, and lived in whatever quarters the Army could provide. But they were IBM employees, paid by IBM, supervised by IBM, and trained by IBM. They were the most visible embodiment of something the American war effort had that no other combatant possessed: a fully developed, commercially maintained infrastructure for large-scale data processing.
The German absence. Germany in 1939 was not without punched card technology. Deutsche Hollerith Maschinengesellschaft, DHOMAG, had been IBM's German subsidiary until the early 1930s and had continued to sell and lease IBM-designed equipment after Watson reluctantly distanced himself from the German operation. The Wehrmacht used DHOMAG equipment for payroll and some personnel records. The Reich Statistical Office used punched cards for the 1939 census. The technology existed.
What Germany did not have was the service infrastructure. DHOMAG had never built anything comparable to IBM's Customer Engineer Corps. The German tradition, as the historian of the Second World War's logistical side has noted, was the tradition of the skilled specialist, the man who understood his machine completely and who was not easily replaced. When German tabulating equipment broke down in a forward headquarters, the repair process was slow because the men who could fix it were scarce and centralized. When the Wehrmacht's Manpower Planning Office in Berlin needed to revise its processing sequences to account for new classification categories, the work took weeks because the institutional knowledge for doing it quickly did not exist in the same distributed, redundant form that IBM had spent 20 years building into its customer engineer network.
The consequences showed up not in any single dramatic failure, but in the cumulative friction of an administration trying to manage a global war without adequate information infrastructure. The German Army's logistics system in the Soviet Union suffered chronically from poor supply tracking. Ammunition, fuel, and spare parts that existed somewhere in the supply chain were frequently invisible to the commanders who needed them, because the data processing capacity to track them accurately and quickly simply was not there. The Red Army, which received American tabulating equipment through Lend-Lease, processed supply requisitions faster in 1944 than the Wehrmacht did.
The numbers that won the Pacific. Nowhere was the IBM infrastructure more consequential than in the Navy's effort to manage the logistics of the Pacific War. The distances involved were unlike anything in the European theater. A supply ship leaving San Francisco for an advance base in the Western Pacific traveled more than 5,000 miles. The base might be supporting operations against a target 2,000 miles further away. The chain of depots, fueling stations, and repair facilities that kept the fleet operational stretched halfway around the world, and every link in that chain required constant tracking.
The Navy's Bureau of Supplies and Accounts had been using punched card tabulation since the 1930s. By 1944, the Bureau was operating the largest tabulating installation in the world at the Navy Supply Depot in Mechanicsburg, Pennsylvania, processing millions of requisitions monthly and maintaining inventory records for more than 1 million distinct stock items. The IBM equipment in that installation occupied an entire building. The IBM engineers who maintained it worked in shifts around the clock. When the tempo of Pacific operations accelerated after the invasion of the Philippines in late 1944, the Bureau added 3 additional shifts, and IBM sent additional engineers from its Endicott training facility to meet the demand. The results were not invisible to the men who depended on them. Admiral Raymond Spruance, commanding the Fifth Fleet during the battles of 1944 and 1945, received daily logistics summaries that told him, with a precision that still impresses historians, exactly how many days of fuel, ammunition, and provisions his fleet could sustain at current consumption rates, and what was in transit to replenish it. That information came from punched card systems. It traveled to him because IBM engineers thousands of miles away kept those systems running.
The Reckoning. When the war ended in August 1945, the demobilization of the American military presented a data processing challenge almost as large as the mobilization had been. 42 million men and women had served in the armed forces. Their pay records, service records, medical records, and discharge papers had to be processed, verified, and filed. Their separation allowances had to be calculated and paid. Their veterans' benefits had to be established. The GI Bill, signed in 1944, had created an enormous new federal obligation. Education benefits, home loan guarantees, unemployment compensation that required tracking millions of individual eligibility determinations.
All of it ran through IBM. The Veterans Administration expanded its tabulating capacity by 400% between 1945 and 1947, leasing new equipment, training new operators, and relying on IBM engineers to make the expansion work faster than the agency's own procurement process could have managed alone. The separation centers that processed discharge papers ran IBM equipment. The finance offices that calculated terminal pay ran IBM equipment. The regional VA offices that processed GI Bill applications ran IBM equipment. When Senator William Langer of North Dakota complained to the Senate in 1946 that veterans were waiting months for their benefits, the Veterans Administration responded, accurately, that it was processing claims faster than any comparable operation in history. The machinery making that possible was IBM's. Thomas Watson collected his reward. In the 4 years between 1941 and 1945, IBM's revenues had grown by more than 200%. The company had trained thousands of new operators and engineers, most of them on government contracts that IBM had negotiated with the argument that training costs were a legitimate war expense. When those trained personnel returned to civilian life after the war, many of them became IBM customers. The engineers who had maintained tabulating rooms in Army Air Force's headquarters, in Pacific Fleet supply depots, in the Pentagon's basement, went back to the same equipment in corporate accounting departments, insurance companies, and universities. They knew how to use it because IBM had made certain they did. Watson had managed to convert the largest public emergency in American history into the most effective sales and training campaign in corporate history. What the war proved. In the autumn of 1945, a team of American intelligence officers examining captured German records at the Reich Statistical Office in Berlin found something unexpected. The filing system was meticulous, the records comprehensive, and the administration clearly competent. But the German statisticians had been doing by hand much of what their American counterparts had been doing by machine. The forms were different, the processing was slower, the reports took longer to compile. Not catastrophically longer. The Germans were skilled administrators, but measurably, consistently, consequentially longer. In a war where operational tempo was itself a weapon, that difference had mattered. The war had not been won by the better calculating machine. No single IBM tabulator had turned the tide of any battle. The machines were not weapons. They were infrastructure, the invisible plumbing of a military-industrial complex that produced, moved, and accounted for resources at a scale the world had never seen. What IBM had given the American military was not an advantage in firepower or technology or strategy. It was an advantage in administrative legibility, the ability to know at any given moment, with reasonable accuracy, what you had, where it was,
and what it would cost to use it. In a war of attrition fought across oceanic distances, that knowledge was worth divisions. The German engineers who examined the organizational charts of American supply depots in France during the winter of 1944 found the tabulating rooms puzzling. They were accustomed to thinking of record-keeping as a clerical function, necessary but peripheral, staffed by women and older men unfit for combat duties. The Americans had staffed their tabulating rooms with trained technicians and kept them running 24 hours a day. They had shipped the machines across the Atlantic and stationed engineers to maintain them. They had made data processing a logistics priority.
The Panther was, on paper, a better tank than the Sherman. The Type 21 U-boat was, on paper, a better submarine than anything the Allies deployed. The German 88mm gun was, by almost any measure, a better anti-aircraft and anti-tank weapon than its American equivalents. Germany had brilliant engineers, world-class metallurgists, and a military tradition that stretched back centuries. What it did not have, in sufficient quantity, was the administrative infrastructure to convert those advantages into sustained operational effectiveness at scale. It did not have the gauge tradition, as the W2 Tales narrator put it. And it did not have IBM. The SS Robert E. Peary was launched in 4 days because Kaiser had mastered interchangeable parts. The Sherman tank was repaired in 4 hours because Knudsen had mastered standardized components. And the army that deployed those tanks knew within 48 hours how many of them were operational, how many were awaiting parts, and how many replacement engines were in transit from Detroit, because Harold Everett and 1,000 men like him were feeding punched cards into IBM machines somewhere in England and France and the Pacific. Germany never answered that question at all. We won because we smothered the enemy in an avalanche of production, the like of which he had never seen nor dreamed possible. William Knudsen, Director of the Office of Production Management, 1945.